Hi, it's Lee from the Japanese Water Gardens. In this video we're going to be finishing off a project that we actually started in the spring. Those of you who watch my channel will remember that we built a quarantine system last winter. The quarantine system was finished during the lockdown, so there was a few things that we basically had to rush to get done, and we didn't finish it off exactly how I would have wanted it to be. The filtration system that we put on has performed extremely well this year, and I wouldn't change anything on that. It's basically a traditional multi-bay gravity fed filter where you have a vortex for spinning and settling out the heavy solids. Then we did this chamber with some K1 micromedia. The K1 micromedia has worked extremely well as a mechanical filter. This sifts out all of the suspended solids and it keeps the water in exceptionally good condition. The water is absolutely crystal clear. That's followed up with a biological chamber here at the end where we've got a lot of biological matting and various other things in there as well. This year during the summer I started developing a new filtration system for this pond, and I never really got it finished. So what we're going to be doing today is we're going to be getting that completed, and I'm going to go through exactly how that one works. This filter is something that I want to get working on this system, because in the coming year when we restock at Easter we're going to be having a lot more fish, and we're going to need to get this thing working properly so that it can keep the water in good condition. Last year we designed and installed our new quarantine system. There are 4 separate bays. Each of the bays has its own bottom drain. There is one filtration system where all of the water combines before returning to each of the bays. A very useful feature allows each of the bays to be isolated and drain down independently. It's just a matter of closing and opening up a few valves. To install my new filter, I am taking a feed out of the side of the largest bay. That's bay 4. When the water had dropped by about 2 feet, I used a pump to transfer some of the water out of the bay into the bay at the side. This would mean that I can save some water, and it will save some time when we refill at the end. When the level was sufficiently low, I switched off the pump. The wooden panels on the front of the tank were made so that they would be easily removable for such an occasion as this. Behind the panelling, we have insulation material to keep the heat in the tank. Heating up large amounts of water is extremely expensive. Proper insulation can save very substantial amounts of money. The feed to the pump is coming straight out the side of the tank below the water line. The pump is not going to go in the water. I drilled through the tank wall. Then added a bulkhead fitting. I often seal these with silicone and find that if I smear a spot of washing up liquid onto my fingers, it smooths them down effortlessly. You can also get rubber seals that some people find preferable. Inside the tank, the open end of the bulkhead needs a cover. After some thought, I decided to make one from a side feed dome. It was the perfect size and would fit flush up to the side of the tank. To let the water through, I drilled a series of small holes. Again, I used some of the silicone to make up a seal. Then I positioned it over the bulkhead and screwed it directly to the side of the tank with 2 stainless steel self-tappers. On the outside of the tank, we needed a control valve. Should I ever need to service the pump, I can shut this valve and carry out the work without the need to drain down the system. This size conveniently glues straight onto the bulkhead. Slide valves are not the most reliable things, but they are compact, affordable, and for this purpose, more than good enough. I was eager to check the seals on the bulkhead, so I opened up the inlet and let the bay fill with water. The dust from the drilling was floating on top, so I skimmed it off with a net. On the outside of the tank, no leaks were visible. I was happy. The valve will need to be accessible, so I measured out for an opening in the side panel. I used the largest hole saw in my box, then cut several holes. I then refitted the panel, cleaned up the opening with a saw. The pump that I am using is a Pontec 8000, a submersible pump that you can strip from its casing and dry mount. They're very inexpensive to buy, reliable, use low amounts of energy, and they are capable of delivering a large flow. I positioned the pump in a space beside the tank, measured and cut pipe with bends to fit. It is useful to lay out everything before you commit and glue. The pump will draw water out of the tank, pass it through the pump and deliver it to the filter. I was happy with the fit, so I broke everything down and started to glue up all of the components. The demountable unions on the pump help to make this much easier. For the connection into the filter, I used a rubber boot fitting. They have some flexibility and are very forgiving. After the comment in a previous video, I invested in a set of socket drivers, much safer than a flathead screwdriver. I could now turn my attention to the filter. Last year I experimented with a rotating spinner system that had a fixed head. It worked, but over time developed some issues with binding. So I wanted to perfect a new design. My new design was using spinners that had no fixings. I made up a pair of heads and put them to the test. I was expecting it to blow off. And it did. Wow. But after a few modifications, some drilling, some tweaking, I had 2 spinners ready to test to destruction. Would they start? I tested them at a variety of speeds and pushed them. Stop. Speed up. Slow down. Faultlessly. Yes. To finish off the job, I added some more of the media. Then, with perfect timing, Angie turned up with a cup of tea.
You stand up on there and have a look at it.
What that, bonbons?
Hang on.
Woo!
What are these are?
What are these?
Put them on top.
I'm not going to get wet through them.
Might get
Oh! Oh wow! I'm loving it!
You don't want it to whack you in the face.
That's brilliant! I like them ball things. Trevor's on the rock, yeah.
Yep.
Modest too.
So, all the work today has been for this. This is what I would term a trickle filter. Some people might refer to it as a backy shower, but that's not really accurate. It's a trickle filter. And a trickle filter is based on an idea that I think was first used by the Victorians. If you're familiar with a water treatment plant, you'll have seen something along these lines. The idea is that the media, which is developing bacteria, is kept moist as opposed to saturated with water. In a conventional filter, which is referred to as a submerged bed filter, the bacteria extracts oxygen from the water and they convert ammonia and nitrites into nitrates. In this type of filter, the bacteria is able to extract the oxygen directly from the atmosphere. So there's a surplus of oxygen. This type of filter is extremely efficient biologically. It can cope with a lot of ammonia, a lot of nitrites, and break it down really quickly because there's an almost unlimited supply of oxygen. Now this type of filter is slightly different to the backy showers because with a backy shower you have a tremendous flow of water, so much so that the water is literally cascading and crashing down through the media. There may be a few advantages to that, but this way, by using this trickle method, you can actually use a very small pump, and that means it's low energy, it means it's cheap to run. The trick is, or rather the problem is, how do you take a small amount of water and disperse it evenly over the surface of your media? It's not easy. It's not easy to create a sprinkler system like this and it work with a small flow, not stop, not get blocked up, not fall to pieces, keep going for months and years. Now I think what will happen eventually on this one is that the fitting, where it's rubbing, where there's that friction there, will eventually wear and it will need to be replaced. But that should be a relatively inexpensive replacement, and it should be dead easy to do because it's accessible, it's at the top. Inside here there's about 300 litres of this media called, I think it's called Katama, and this is the kind of media that's going to work extremely well in something like this because it's porous, extremely porous. It's a uniform size, so it's easy to fill a container, and I think it's going to work extremely well. When you've built a rotating spray bar, you're always going to find that there's certain areas that get more water spraying on it than others, and I think that's pretty much unavoidable. But we've not done a bad job here, and I'll keep you posted and I'll let you know how it's getting on.
If you would like me to make a future video explaining more about how to make these spinners, then thumbs up this video, leave a comment and subscribe to the channel. It's bye for now from Lee at the Japanese Water Gardens.